know, in today's episode we're going to keep working on this old 1956 Volkswagen Beetle. We're actually going to install the patch we made back in episode number 1, and along the way I'm going to share with you a few techniques and tricks to replace a sheet metal panel in pretty much any car. So that's today in the garage. Well, when you're doing body work, there's three main ways to put metal together. The most common by far is your regular butt weld. You take two pieces of sheet metal, you butt them together with a small gap between, and you weld along that. The second is a lap weld, where they're actually overlapped. But in order to do this, you can flange one edge of the metal. This is a flanging tool, air-powered. What that has done is it's put a step into the metal so that I can place my other metal on top and now have a flat surface to work with. So here for our butt welding, I've aligned the two parts with about a 1/16 of an inch gap between them, and I'm just going to tack weld them in place. Tack weld is just held for a second or two. And with the tacks in place, I can reduce the amperage on the welder, and I can fill in between my tack welds. The second technique shows the lap weld, where I've used the stepping tool to make a step for the new piece of metal to fit flush. This is a great way for beginners to start welding, because what you wind up having is really an extra thickness of metal to work with, so you're less likely to blow through the weld. I use my left hand to support the nozzle of the MIG welder to make sure I'm the correct distance at all times. The third and final technique is representative of how most vehicles are put together, and that's spot welds. Here I've just made a piece of bent steel that might resemble a new panel that you're going to put in place on top of the old. And I've punched a number of holes in it. These will be filled with the MIG welder, and it's called rosette welding, and ultimately the result should look a lot like a spot weld from the factory. So in this case, I can simply vice grip the two parts together. I'll use the MIG welding clamp on the other side, the ground clamp, as a way to hold the parts together. And now I need to fill those holes with weld material. For rosette welding, I always use a slightly higher amperage than I would in a normal weld on flat steel. I like to start from the center of the hole and work in a spiral outwards to make sure I get adequate penetration into both parts. Now occasionally you'll get a hole, and I allow the weld to cool till it's no longer red, and then just tack in place on top of it and fill that extra hole. With all the welds filled in, it's time to take the angle grinder, grind off the excess metal, take a sander and smooth it out, and we'll see how these examples look in just a few minutes. With a little bit more sanding and grinding, you'll have your pieces of metal fully joined. Now here is the butt welded part. This is probably the best way to join metal when you're working on a car. Done right, it's seamless. It'll only need a skiff of body filler, if that. If you control the heat, you won't get any bowing or bending. And the good news is that you could also fully grind down and sand the backside, and really, you could make it so that no one would ever know that a panel had been replaced. The lap welded or flange seam is also equally effective at being hidden from the outside. But the backside, you're always going to know that a replacement's been done. What I would suggest if you use this technique for welding in a replacement patch is make sure when you're done you can go back in and put a seam sealer along here, or else that's one heck of a trap for water to sit and cause future rust. The third technique was showing our spot welding technique, or rosette welding. This is a very common way for putting full panels on a vehicle, or for example floors into a Volkswagen. That's the way the cars were made originally. And if you space your holes correctly and you carefully rosette weld and grind, you can give the appearance of a factory finish. And the appearance also appears like a factory spot weld on the backside. Well, the first step to making a sheet metal patch repair is to make sure that your patch that you've made fits perfectly. Now, the good thing about making your own patch like we did is that you already know it's going to fit perfectly. And in fact it does. But there's one quick detail that we may miss out on had we acted in haste. And in this case, as you can see, there are fender bolt mounting holes all the way along. They're actually a captive nut that's welded into the sheet metal. Now if I went ahead and installed my patch without first putting a captive nut in it, we'd have a tough time holding this fender on. So the first order of business, before we can even think about welding this in, is to make sure that we install a captive nut right in place on the new patch panel where it was on the original. If you look on the back side of the panel we removed, you can see there's a custom style captive nut that's welded right in place, and the bolt's just sheared out of that. And obviously our new part doesn't have one. Now all we need to do really is locate this hole in the new part, drill it, and then weld in a nut. Now we could weld in a nut, but since we're trying to do a proper restoration with every detail correct, why not weld in the right nut, which is the actual style of captive nut that was used at the factory. These are available for Volkswagen, so we may as well use it. So let's locate this hole, drill it, and tack this into place. And with the hole drilled, let's make one more check before we weld in the captive nut. You can do this by just laying the new part over top of the old, lining up all the edges, and I'd say we're bang on. It might seem to be a struggle to find the exact location for this and then somehow get your vice grips in there to clamp this down. But a quick idea to make it work: hey, after all, this is a nut, so why not put the bolt through on the other side and just screw it down into place. That ought to do it. So with my welding equipment on, something comfortable to sit on, body hammer in hand, dolly in hand, I'm ready to weld this panel in. Now I've clamped it in place, making sure my body line here lines up, and as I've mentioned in previous episodes, the important thing as I see it is to get the main key features. There's a crease here and a crease here. Get them lined up, use your hands to make sure you're flush, and make the first most important tack weld to make sure that it's held in place in the right spot. A big part of welding in a panel is making finite adjustments to make it fit. And time spent here is time well spent. Take your time. If you mess something up, cut it out and do it again. I see here that using my eyes and using my finger, that my panel is just a little bit proud of the original panel. So because I'm clamped here, it'll probably stay in place if I just simply give it a few light taps. That's coming nicely in line now. Once I feel that it's in a place that it can stay, I'll tack it again. Now with some adjustment, I'm quite happy with the alignment right here, so I'm going to tack that in. It's going to start to need some adjustment and persuasion as we move along now. Now the metal's popped right where I want it, so I'll tack in there. With the initial tacks made, we can now slowly turn the settings down on the welder and work our way around and fill this in fully. One great trick when you're working on sheet metal, I've always found, is to make sure you're resting the nozzle on something firm, like your hand. If you notice, a surgeon never uses a scalpel to cut flesh without resting the pinky finger on what he's cutting. And the reason for that is otherwise your hand is jittery. So when you're trying to be a consistent distance from the metal and your hand is free, you're going to inevitably have bad spots in your weld. So by resting the nozzle on your hand, you can do what you need to do to get a good weld. Now here is an instance where I've placed a pair of vice grips just on this seam, but it's also a great rest for my hand, so I can work along here without my hand being tired. So I'll get to work. As the work continues, it's really important to take a break from time to time. You do not want to build up the heat in this part. That's why we dance around from one spot to the opposite side, and then back to somewhere in the middle, and then around and around, to keep the heat from being concentrated in one area. That heat will inevitably warp the metal, and it'll be very difficult to get it back out with a hammer and dolly. So take your time. This gash and these little pinholes, they need to be filled with metal, and you can do that with a welder. One of the neat things about copper, it's a non-ferrous metal, and you can't weld to it. As much as you try, this welder will not weld copper, which means you can put it in behind a pinhole, and it'll act as a backing to help you fill in the hole. By the way, this is just a 1/2-inch copper pipe, flattened with a hammer at one end, and I've put a bolt down on the other end to give it some weight. Well, whether you're rosette welding, lap welding, or butt welding like we did here, with some hard work and perseverance, you too can learn how to replace a panel and make the car good as new. So until next time, get out to your garage and burn the midnight oil.